Thank you for joining. I'm really happy to be a guest in Chaim Michael channel to give this lecture because Chaim was my lecturer uh, 20, 13 years ago, and this is my thanks for him. And I will introduce myself first. Okay, I'm sorry. I'm 50 years old, and I'm married. I have two daughters. And I'm mobile developer since 2011. Before that, I was a hardware developer. I worked for Motorola 16 years, and I took one course with Chaim, and this course changed my life. And now I'm working for Android, and today I'm working in the company named Intent HQ. This company is a Britain company that acquires my company that used to name Anagog, and we develop a mobile SDK for iOS and Android. And I'm also a certified glider pilot. This is my hobby. Okay, and as you see, I'm a senior mobile developer. And today we're going to talk about developing apps in cross-platform technologies. So we know that we have, when we want to develop a mobile app, we have two ways to do that. We have the native way, and we have the cross-platform way. And the native development is the traditional development that we develop apps for iOS and Android. We do this for each platform. We have the design tools to do this. For iOS, we use the Xcode. We write the code in Swift programming language, and we use the UX UI native components of iOS, the view controllers. We have Swift UI now. It's a new way to develop UI in iOS. And for Android, we use the Android Studio. We have the Kotlin language or Java, and we use the native UI UX of Android, which is vue.java. Or we can use Jetpack Compose now. This is the new way that we develop UI in Android, but the traditional way, and still there are many apps there that use the traditional UI developing with views and XMLs that inflated to view objects. And this is the native way, okay? And the advantages for developing in native are that we have full control of accessing the platform services. If we want to access the camera, if we want to access the Google Play services, to get location, to get activity, motion and activity, if you want to identify if the user is riding the bike or driving a car, okay, these kind of APIs, we can get them from the platform native services, and we have full access to these services when we develop native mobile apps. We have high performance UI and UX. We can have full control on the UI, and therefore we have good performance because we have direct access to the UI objects. We can have background processes easily. We can run background processes like services, broadcast receivers. We can run workers in Android. Okay, in iOS we can have the background fetch and APIs, and we have full access to these services, to these processes. And the problem with native development is that first, we have to have two separated teams for iOS and Android. Each team, it's a higher cost because we have to have two developers for each platform. We have different development attitudes. iOS developers have their own terminology. They speak the same language as well as Android developers. We have our own tools. We have Dagger, we have Retrofit, right? This is for Android. If we want to develop for iOS, we use Alamo Fire. We use other libraries that only iOS developers knows. So each team has different attitude, different architecture, and different guidelines for developing the application. And this takes longer because when we're developing in parallel, two groups starting developing the app, Each team has their own problems and they reach the goals in different times. So it might take longer to develop a native app. And therefore, we can, and we say sometimes, why should we develop the app twice? Why should we develop the same application, the same screen twice, if it's doing the same? Okay, why should we develop the login screen twice? Why should we develop the onboarding flow twice? It's the same screen, it's the same UI. And therefore, they came out with cross-platform technologies, which means we write the code once and we get the same application for both platforms. Okay, it's kind of a magic, right? It's kind of too good to be true. And therefore, they came out with few frameworks for cross-platform. And the most popular cross-platform framework out there are ReactNative, which came from Facebook, and Flutter, which came from Google. The React Native applications, they are written in JavaScript and TypeScript, and they are based on the HTML, CSS ecosystem. And we write the code, we write the application very similar to a front-end application. And the Flutter framework, this is a new technology from Google, and we use Android Studio, or we can use VS Code to write the code. But this technology based on the Dart programming language, and it's a quite new language that came from Google, and we use the Dart programming language to write the code. And the Dart, it will be the code base. The code base will be written in Dart. And by the way, later in this lecture, I will show you a way to identify if a mobile app developed in Flutter, okay? Stay tuned. If you see a mobile app on your device, and I can prove to you that this is a special application, and in most chances, it was written in Flutter, okay? In Android. The advantages of cross-platform is that we have one language both for the code and for the team. And it's the same architecture, it's the same terminology. Each platform, React Native or Flutter, has their terminology, has their way of thinking, the Flutter way or the React Native way, and all the team speaks this language. There are no different attitudes, right? It's costless because we can have many less developers, and we have one app and one team. And we get faster time to market. This is crucial. If we want to develop a product and we want to get it fast to the market, maybe it's better to consider to use cross-platform. And also, we can use our front-end developers can develop a mobile application when it comes to React Native. And that's why React Native is very popular in the market, because companies that have already front-end developers, they can shift easily to develop a cross-platform app with React Native. And I'm seeing this a lot, okay? Because I'm developing an SDK, which works both on Android and iOS, our customers that want to integrate the SDK, I see that many customers are cross-platform, and many of them are React Native, especially in India or in Europe, okay? I see many customers that comes with React Native. I believe that it's because they choose this technology because they have already mobile front-end developers that use JavaScript or TypeScript. Well, there are problems with cross-platform. In some cases, the UI performance might be low, especially in React Native, yes, because React Native uses many bridges to render the UI on the device. This might gives you less power when it comes to animations or when it comes to platform changes or updates that changing the UI components, this can cause problems in React Native. The application APK or the application size is much more bigger. So if a native app, maybe it takes 10 megabyte, a cross-platform app might take 50, okay, or even more. And we have limited access to the device services. If we want to access the GPS, if we want to access the camera, if we want to access sensors, in a cross-platform application, it will be harder. We will need to have platform channels. We will need to use third-party plugins that developed for us in order to save us a boilerplate for accessing platform services. All right, because in a cross-platform app, the developer doesn't know how to access the device hardware because it has the JavaScript language or the Dart language doesn't have the APIs to access the underlying services. So it will need some kind of a channel to do that. So this is a problem. So this brings us to the requirement to be depend on many libraries, open source, that we will need to integrate in our application in order to do things. And this can be a problem because we know that we have many libraries, we have conjunctions, we have version issues that we need to update a plugin or a library, and this causes us to update the rest of the plugins because the new library demands a new SDK version, and all this stuff causing us a nightmare of updating and maintenance. Okay, so the maintenance will be harder, and I see this all the time. So we do have a cost saving, but we do have development cycle that might be longer because of these problems. And also we have limited background capabilities. When we want to run things in background, the cross-platform won't help us to initiate a service in Android. It won't help us to send a broadcast in Android because the broadcast or intent objects or it doesn't accessible from the cross-platform environment. But the end, what we have here, we have application that written in a single code base, most of it, and then we use the native tools to build the application in Android Studio. We still use the Gradle to build the application. We still need to use the Xcode archive to pack the application and to publish it to the Play Store or to the Google Play Store, okay? Now, this graph illustrates the popularity of the GitHub repositories for React Native and Flutter. And you can see that React Native came out on 2015, and it becomes popular. And Flutter was developed and introduced in 2017. And since then, the popularity of Flutter really skyrocketed. Okay, you can see the trajectory of the popularity in terms of the GitHub repo stars. Okay, the developers, they like this repository. Both of them are open source. I didn't say that. They both open source. And you can see that Flutter is very popular also in the application store, in the Google Play Store. There are many Flutter applications beside React Native application. Now we will see the difference between these platforms. We understand what is the major difference between them, okay? First of all, the platforms, the Flutter technology brought us from Google, and the React Native came from Facebook. But React Native using the TypeScript language and Flutter using the Dart programming language. The UI rendering is one of the most significant differences between React Native and Flutter. Flutter using a rendering engine to draw the UI directly on the device canvas, while React Native using the UI components of the platform. If we know that we are developing for Android, we are using text view, we are using recycler view, we are using buttons, right? And these coming from the Vue ecosystem, Vue.java, and all the UI components inherits from the Vue class. And this how React Native works. It uses the native UI components of the platform. When we see a button on the screen in React Native, it's a button.java that comes from Android, okay? When we see a text, it might be a text view from the Android Vue ecosystem, while in Flutter, it's totally different. A text view doesn't exist in the Flutter world. A button doesn't exist, or recycler view doesn't exist in the Flutter world, okay? Therefore, the performance, the UI performance in Flutter might be much more better because Flutter owns every pixel on the screen. It's similarly to gaming frameworks like Unity that draws the characters on the screen. Flutter does the same. It takes the canvas, it's just drawing the UI, and it looks as it was a native view, okay? Also, both frameworks have the hot reload capability. This is nice. When we develop an application, we use the hot reload to see the changes on the screen immediately. We don't need to run it to rebuild the application every time. Once we change the UI, it will affect immediately on the screen. This works the same in React Native and Android. And again, as in the UI perspective, we have better customization capabilities in Flutter to do custom UI components rather in React Native. Okay, the learning curve is much more higher in the Flutter world because we need to learn the Dart programming language. I think it's very easy language to learn because it takes from all languages. It's a object oriented. We can use inheritance, we can use interfaces, we can use composition, okay, design patterns that we love if we develop in object oriented. We can create architecture that we used to know from Android or from iOS. So, but the learning curve still, we need to learn it. And for React Native, it's easier because if we know already JavaScript and we know TypeScript, so it's easier to develop a React Native application immediately. The testing support in Flutter is excellent. We have the full test ecosystem coming out of the box. We have unit test, widget test, integration tests, okay? Also in React Native, we have good testing options. Also, we have differences in terms, this is a very, very, very important difference between Flutter and React Native again. The compilation issue here is different. The Dart programming language is compiled directly to the machine language of the device processor. So after we compile the application, we get native code, pure native code that runs on the device. While in JavaScript and React Native, the JavaScript code runs on a JavaScript engine on the device. And from there, there is a bridge that interpolates the JavaScript engine's operation into UI components that are on the screen and also to accessing the device services. So Flutter doesn't have this kind of a bridge, and it doesn't need an engine to run inside of it. It just compiles to pure native processor language. So it has no limitation in terms of performance. All right. Now, the languages are, as I said, they are different. The Dart programming language is an object-oriented. It has functional capabilities. it's strongly typed. So if we define a member and it has a class type, so it's strongly typed. It has null safety. We can control nullables or and easily, like in Kotlin, we have the null safety character that we use, and both languages utilize the asynchronous programming paradigms like future and await and promises. This is the same in Flutter or React Native. And both platforms, if we want to access the device services, to access hardware, we use platform channels in Flutter or native modules in Android. For example, if we want to grant permissions, okay? You know that Android application has permissions, right? And we want to grant location permission, and we want to grant location permission in iOS. This will be done using the platform channels to access the services in Android to request the permission, and also in iOS. So usually we are using third-party library that already written in Dart or in JavaScript to invoke these kind of APIs to request the permission, okay, to request location, but it's using the native modules or the platform channels under the hood. All right, and also we have the threading issue. The Dart language is a single-threaded, but we can use multi-threading using isolates. This is out of the topic of this lecture, but we know I can tell you that in Dart we still can have multi-threading, while in JavaScript and in React Native it's a single-threaded, and I don't know if there is some kind of a threading possibility in React. Okay, now this diagram, as I said earlier, illustrates the difference between React Native and Flutter in terms of the native code. As you see, the React Native has the JavaScript. It runs on the JavaScript engine, and it needs the bridge to interpolate the JavaScript engine in order to draw OEM widgets on the screen. And the bridge is also used to access the services. While Flutter, first of all, there is a native code. The native code, when I say native code in this context, I'm not talking about Kotlin or Java native code. I'm talking about the native code of the platform, of the processor, because the Dart programming language compiles into native code that runs directly on the device processor, ARM processor or x86 processor. And from there, it's just using the widget rendering engine, the Skia engine or Impeller. Impeller is the new engine for drawing widgets on the screen. And from there, it goes directly to the canvas. And we see the items on the screen as they were. It's not real UI components for Android. It's just looked like this, okay? It's an illusion. All right, so you see the OEM widgets are actually text view or recycler view or list view and view group, okay? In Android, we have view group, or view controllers in iOS. Now, I wanted to talk now about very fundamental change when we are developing cross-platform application. We know that we have two ways to draw a UI. The declarative way, to write the code that controls the UI. The declarative way, which is the way that we do in cross-platform applications, and the imperative way that we used to do in the traditional native development. If we know Android development, when we started to develop for Android, when we wanted to change a UI component, we need to create a reference object for this component, and then we can use setters and getters to manipulate this object, right? We use the find view by ID to create a reference to an object. Then we use the setters, or we use methods that provided us by this object to manipulate it. And this actually makes the object mutable. So we create an object and we use to manipulate it in order to change it and in order to listen to events from it. But in the declarative way, we have single line of code that sets the whole UI, and once it was created, it cannot be changed. It's immutable object that we create in the bottom example, okay? In the bottom example, over here, you can see that we create an object that described view B. View B, it's the view group, the yellow view group. We can set its attribute right when we created it, okay? We set the column object that described a column of vertical objects that are arranged one below the other, and we set the views immediately once it was created. And this cost us a single line of code. And most important, we don't have any reference to an object that can be changed during time. So if we want to change the view, we need to create a new object, and then it will be re-rendered on the screen after we create a new one, okay? So this is the difference between declarative and imperative, because declarative way is the new way to draw and to create UI in mobile. Even Android and Swift native now adopt this idea. In Android, it's called Jetpack Compose. In iOS, it's called Swift UI. And we're no longer using XMLs to inflate UI objects, okay? This is history, okay? By the way, React Native still using the view as we see. I mean, when we develop the application, we use the declarative way, but after that, we are getting objects that are actually comes from the native world, which are objects of views, okay? Let's continue. So this is just a comparison between the declarative way and the imperative way. But the most thing that we need to understand is that the mutability issue. In declarative way, the UI is immutable. If we want to change the UI, we need to change the whole UI or the whole component again. And we don't have any reference to an object that represents a UI component. No way. All right? And you can see that the imperative way, we used it in Android, in XML or Java. In iOS, it was the view controller. The declarative way is Jetpack Compose, Flutter, ReactNative, Swift UI. All right? Okay, so if we want to develop a little application, we want to do this. Let's see how we do this in 3 technologies: in the native way, the traditional way, and also in React Native or Flutter. Let's see. Okay. So in the old way, in the native way, we used to have a layout XML. The layout XML contained the button. It contained the view group. Inside of it, we had the child group views that is a button, a text view. These XMLs were inflated. Inflated, it means it takes the XML and create a Java object from this XML. This thing cost us performance. Inflating XML to an object is cost effective in terms of performance. Later, we used in our fragment, we created an object from these components in the UI using the find view by ID. And we have a reference to the button, we have a reference to the text view, and we used the set on click listener setter to set a listener. So we changed the object of the button. And also once we click the button, we use the set text of the text view to change the text. So this was explicitly done in runtime by accessing the object and change its way to show different things on the screen. Okay? Now, if we look on a Flutter and React Native application for similar application, all right? First of all, if we remember the Android application, we use the main activity as an entry point. We use the application class as the entry point, and we use the set content view to show the UI, right? Now, in Flutter and React, it's different. There are no activity, no fragments, no view controllers, none of these, okay? What we do have is, first of all, we have the application entry point. The application entry point. In Flutter, it's the main function. The main function is the entry point of the application. In React Native, the entry point is just a Lambda function that represents an object, that this object returns the UI that will be shown on the screen. And if you ask, where do we reference to this app object? If you know web application or node application, it's referenced in the index.js, index.html file that is actually the entry point of the node application or web application. This will create an object from the application Lambda and will return the view that comes from the React Native framework. So instead of taking object from React, if you was developing for React frontend, you took components from React. You imported objects from React. Here you imported them from React Native. This is just a library that you include in your node application, okay? Later, in the Flutter application, you see that the run application, the run app function, create an object from the MyApp class. The MyApp class is just a class, but it extends a stateless widget. So I didn't talk yet about widgets in Flutter, but you can see that the Flutter application is an instance of an object, okay? An instance of an object that inherit a stateless widget. A stateless widget has the build method needs to override, and the build method returns an object, a widget. So what we see is that the whole application is a widget, and it returns a widget that represents our application. In React Native, you don't have the you don't inherit from any object. You just return the whole view, okay? In Flutter, on the other hand, you create an object for them. By the way, this is a single line of code. In Flutter, the return line is a single line of code. It's just arranged as a structure. But if you can see, we just create an object from the material app widget, and this content is just a properties inside the material app. And at the bottom, you see that we have, I don't want to get in the whole properties of here. What is the scaffold? But let's talk about the body. The body has the center widget, which wraps a children object that is the button. And the button has an attribute for the on pressed. When we press the button, it triggers the handle click method, and it's and here it just changed it just write the event to the log. We didn't saw here how we changed the text yet, but what you can see here first, we don't have any reference to UI objects in the code. No. And the build method, once it runs, nothing will rerun it. So once the build method executed, the UI is shown and you cannot change it. You can change it if we use stateful widget. I will show you in a minute. But as you can see, there are no reference to UI component, no references to object, and we don't use setter and getters to change objects. So the UI here and the whole application is immutable. All right. So let's continue. And let's see how we create a list of items on the screen. This is thing that we do all the time, right? We have a list of objects, list of items in the shopping cart, list of items in our online store, right? And we want to show it on the screen. So in the native world, what? I don't hear you. We are muted.
Just mentioned that we are, we have the time schedule and people probably have something
Okay,
next.
so
And so, yeah, we can try to
make it shorter.
yeah, because yeah.
So I tell you what, I want to jump to the end, okay? Because I have many slides, okay? But what I want to show you, I promise that I will show you how you can recognize application if it was developed in Flutter or or React, okay? So this is my last slide, okay? I created a lot of content here, much more for an hour, okay? So let me jump to the last slide. Okay, I will show you this, okay? It's nice. First of all, I prepared a video, okay? You can see my phone. You can see two applications. One application, this is for my company, okay? This is application that I developed. It's a very simple application, a few buttons on the screen, okay, with text. This is the React Native one, and this is the Flutter one. Now I will show you how you can tell that this is a Flutter application, okay? Because if you see, look on the screen, you cannot identify that this is Flutter or React, right? So what we should do here is we go to the developer options, okay? We go to the developer options and we enable the show layout bounds, okay? You see show layout bounds over here. Let's see this. Right. And what we see here, we see the UI components boundaries. It helps us to develop UI. And when you can see here that all these components, even on this screen, has their bounds, right? Surrounding. Let's continue to see what's happening. Now let's open the React Native application. Okay. Sorry. I don't know why it caused it to jump. Okay, we are enabling the show layout bounds. All right. Now we opens the React Native application again. Okay. Right. You see, in the React Native, you still see the components. You see the boundaries of the UI components. And why is that? Because React Native using the OEM widgets of the platform, and you can see the bounds of it. But if you open the Flutter application, you can see even the alert dialogues has native components on them. All right. Now, if you move to the Flutter application, I'm sorry. You can see that the Flutter application, you don't see the boundaries. And why is that? Because Flutter just drawing on the screen the UI components. You won't see anything. Okay. And sorry. And also I want to show you a little thing. I want to show you, check out the Pango application, okay? The Pango application, this is the Pango application. It's the application for parking and public transportation in Israel. Now, you can see that it's native application. You can see the boundaries of the UI components. It can be React Native, but I believe this is a native application. But check this out. There is one screen on this application that is different. And this is the public transportation screen, okay? When we go inside this screen, Do you see the difference? You don't see any boundaries of the UI components. This means that they probably added Flutter screen to their application. They used Flutter add to app. Add to app is the way that you can integrate Flutter screens into your application. If you have a native application, you can integrate native component Flutter screens in your application. Okay, and this is you can see that this screen is different. Okay, and it's interesting to see this. So if you have questions, because this is the end actually, because we have.
Hi, can I ask two questions?
Yes.
The first one is on this screen. How can you tell for sure that this is like a Flutter, and it might be also like a web view, no?
It might be also a web view. I agree. You cannot tell for sure, okay, that this is.
Just a moment. I will mute everyone and just. Okay, please, Moti.
I cannot tell you for 100%, okay, that this is not a web view, okay? But because I see that the theme is the same as the application, I think it will be harder to make it look the same as the rest of the application if it was a web view, okay? Because you can create easily one pixel perfect UI components in Flutter that will look the same as your other UI elements and adopt the whole application theme, rather if it was a web view. Okay. Okay.
Can I ask another question? You said about the background fetch, so it's harder to implement. Is it possible to implement in the core platform?
It's possible to implement. Eventually, it will work on the iOS native side. You can send events back to the Dart world using platform channels. You can do that. But in order to trigger this is out of your control. The background fetch, if I know in iOS, is something that happens occasionally on the nature of the system, right? And you don't control it. But if you want to get events from this, it is possible, but it's much more complicated. It's much more complicated. I agree.
I think you can say that nearly everything is possible. It is a question of how difficult it will be, how many technologies you will need to learn in order to implement it. But nearly everything. I don't say everything because there is, who knows? I don't know everything, but nearly everything from my experience can be implemented. You can always add something to anything you develop, no matter which technology you were using. However, it might be difficult. It might be with performance problems. So, okay. I see a few more questions here I would like to cover. There is a question about AI development, how AI development is going to affect the traditional methods of mobile and web development. It's a question for maybe another meetup. AI influence in all domains on software development, and if you still don't use AI, check out the possibilities. There are lots of things that AI can help you with, which will speed up the development. But however, AI doesn't, at least for now, replace completely, absolutely a developer. It can replace maybe a junior developer, but can't replace all developers. And it doesn't seem to happen, not even in the long run. Eventually, you will need someone to control AI, to use AI, to tell it what to do. What is the future? I don't know. Now, there is a question from MM, 4 questions. Do you see the question, Moti?
Sorry, but chat. Let me see.
Yeah. There was also a question about whether Google is going to kill Flutter, and end the development. Well, technologies come and go. Trust me, I'm into this field for many years, and I've seen many technologies with huge hype arrive and then leave and go away. So eventually, nearly every technology at some point leave us or go off the stage and make some room for other technologies. It is part of the development, evolvement of our world, the hardware, the computing resources, everything together brings eventually leads to a development of new technologies, new possibilities, and it is the nature of software development. At some point, every technology move aside and make some room for new technologies to take the spot. And so now you see that the questions by MM?
Yes, why did Google even pushed hard Flutter if they already deep invested in Android? It's a good question. It's a good question. I think that they in Android, okay, the development became more like building blocks that they added during the years, okay? The architecture, the recommended architecture was evolved. They started with MVP, then MVVM, okay? The UI also, it was based on Java until they came out with Jetpack Compose. So I think they just wanted to create a framework that will be developed from the beginning as the way to develop mobile applications. And it has, let's say, clear table to a framework which has all the tools that you need to develop a mobile app easily. And also the cross-platform demands from the market. React Native was coming and is a big competitor in the mobile development. Since React Native was introduced, there are huge tons of applications created with React Native. So I believe it was a competition issue. Okay, they want to drop from Java, to drop from Kotlin, and use their own language, the Dart programming language. This is one of the reasons I believe that caused them to introduce Flutter. Also, regarding the first question, I think that yes, Flutter has some. I also saw during last week, the last year, many questions about it. What is the future of Flutter? If it will be abandoned? There is a fork that was created a few months ago from Flutter project. It's called Folk, I think. It comes out from Flutter developers that fork the project. And this is a good question, but still the community is working. The documentation is rich. There are always new versions coming out, so they are not abandoned it yet, and I don't think that they will abandon it in the future, in the near future. This is I'm probably sure. Okay.
I just want to add, in the beginning, when mobile development started, and trust me, I have been there. I started developing in J2ME, Java 2 Micro Edition, 25 years ago. In the beginning, it was clear that the development will be done in Java or another static type programming language, and the APIs evolved. At some point, J2ME by the way, this is just one sample for a technology that came with huge hype, and then at 2007, when iOS came out, no one wanted to continue using J2ME. Today, these days, no one knows what J2ME is. Now, the problem both with Android and iOS, in my opinion, is that at some point it became too difficult for developers to develop fast enough to be, it is important to be fast, and time to market is highly important. the development itself became very complex. There was a need by the developer to be familiar with many topics, to be excellent developer. It was difficult to find developers, excellent developers, and Facebook, that as the mobile app, in the beginning they tried a hybrid approach. I mean, a simple app in Java with most code in JavaScript running inside the web view, and similar thing for iOS. And they encountered problems because the computing power of the web browser, which is the web view object, wasn't good enough. And then they took a decision to invent something that will allow them to be faster in their development process, adding features and so on. So they develop an alternative for simple native development. They develop ReactNative. Now, ReactNative and Flutter, this is one approach. There are other approaches. I mean, you have the ability to develop in C# and get apps for multiple, both iOS and Android. It used to be called Monodroid, and then they changed the name for Xamarin. You can develop in Kotlin, multi-platform, and get 2 versions. There are lots of possibilities, lots of framework. You can take Unity 3D that developers use for games and use it for applications. You can develop applications using Flash. There are so many possibilities that eventually it isn't about which one is the best. It is about which one is the best choice for the best selection for a specific project. And there are many things to take into consideration. Bottom line, native development these days still exists, but most companies found cheaper alternatives such as Flutter and ReactNative. Now, about Google, like any other company, like any other big company, they play in many playgrounds. They don't put all cards on one option. They are big, rich, so they can afford that and put money in separated development teams to work on alternative approaches. So this is what they do. And who knows, maybe one day they will announce a new OS for mobile telephones instead of Android and Chrome OS. Who knows? No one knows the future. But in big companies, they put cards on more than one option. So this is what they do.
Yes, thank you, Chaim. Now, there is a question about Kotlin multi-platform, I think, right? And you mentioned it, and I didn't mention it in my lecture, but because I didn't have enough time. But yes, there is the Kotlin multi-platform. It's a new cross-platform technology from JetBrains that can be used to develop cross-platform. But as far as I know, it still requires to have knowledge in the native world. You still need to know Swift and Kotlin. I mean, the Android native language, you still need to know it. While in Flutter, you can develop full application without writing single line of code of native code. I mean, Kotlin or Swift. Okay, this is possible. If your application is built only on UI and APIs and networking, there are many applications like this. So you can have a full application written in Dart or written in React Native, and single line of code of the native world is not required. So I think this is a huge benefit. Now, regarding the Flutter Web question, I think yes, Flutter Web. I don't think it's much popular. Although I think it's released and it's ready for production, but maybe companies that have front-end developers that already developed in React or Angular, I don't find why they should do this in Flutter, really, because I think to create single application that works both for mobile and for web, it's a quite of, I think it's quite of trying to do everything in one code base. I think it's too risky. It's too risky because mobile, when your app works on mobile, you have a different environment which the application is running in, and it's different way of thinking of developing the application. And if the same application works also in the web, so there are no assets like location, permissions, okay? It's different. So you need to manage the code in it's a single code base, right? So if you want it to work also on the web, you need to have in the code different cases for web and different UI rendering for web. So that's the reason I think why it's not so popular. Okay. All right.
Just let me. Question three, I mean, about selecting the technology, there are so many factors you need to take into account. So there are cases that in which you might want React Native, and there are cases in which Flutter might fit better. There are many criteria. I also feel that from other questions that maybe you want to also want to ask whether learning Flutter can help me in the job market. I don't recommend putting effort on in the job market and in the direction of working in mobile development or client side on the web. These two domains are very dynamic, technology change, and I think that when it comes to finding a job, it is better to make an effort and put an effort in on the server side and try to find a job there. More stability, less changes. You learn something, you can find a good job. And this is my advice for people that want to find a job. Yeah, sorry.
Okay, and last mention about Michael, that you said about that Flutter is not so popular, and I agree. I agree that if you go look for a job, okay, if I'm getting into LinkedIn on local leads, I don't see many Flutter, but I do get proposals for Flutter, not many. But I think that as a company that has customers all over the world, I see that there are customers with Flutter applications, but the React Native is if we get a customer for cross-platform, probably it will be React. Probably it will be React. And I think this is because, as I mentioned earlier in the lecture, that React Native is better for companies that have front-end developers in-house. So they are moved to React Native easily. So this is why they choose React Native. And I understand this. But in terms of performance and in terms of capabilities, what you can do in React Native or Flutter, I think Flutter is better. But not always Flutter, the best tool is the one that rules, okay? Because in terms of performance, I worked in a company that the CEO told me, Moti, I don't care about technology. Okay, I don't care if the product is made in React Native or Flutter or native. All I want to do, I want that my customers will be satisfied.
Exactly.
Okay, and he chose to work with Flutter, but it wasn't because it's eventually they choose Flutter. Okay, but as he said, I don't care about technology. I want that my customers will be satisfied. And for their purpose, Flutter was enough. Flutter was good, and it worked.
I want to add, it is highly important in each project to really think about everything, take all factors into account, and then select the best technology for the specific company, for the specific project. You need to take everything into account because everything influences on everything. And I don't think it is even possible to make an algorithm for selecting the best technology for a specific project in a specific company because there are always factors that you cannot even think about. I can give you one example. I had a neighbor in another company next to my office. They develop a product, an application that needs to have a control of the camera. They started with React Native. They thought it would work. The React Native developer knew React Native. He wasn't aware of the other technologies. And then they had problems and specific things they wanted to do with the camera, failed, customers that didn't like the product. So they started all over a year after doing it in native in Kotlin. So they paid a huge price just because they were they didn't stop. They didn't took the decision properly. They were in a rush, moved forward without being even aware of the fact that maybe for their specific project, React Native won't deliver. And indeed, React Native didn't deliver in that specific project.
I can tell you that I saw a few customers that comes to our company that came from India, like and from Brazil, okay? That they have millions of users, okay? Millions of users, and they are using React Native or they are using Flutter. So it's working.
It's Facebook use React Native because Facebook, it is a great demo for React Native. It works. It works for Facebook application. It works for many other companies. I don't say React Native is bad. I can even share that I have in mind a project I'm thinking about using React Native in that specific project. But you can't take that decision automatically. You need to reconsider in every project everything and select the best technology for that specific project and for that specific company. And you must take into account not just technology factors, but also business factors. Everything eventually comes together, and you can take the best decision if you have the knowledge, if you are familiar with all the possible technologies. And unfortunately, I see that happen again and again. Technology leaders in various companies are not open-minded, not enough open-minded, don't have enough experience, and are not aware of the possibilities. And due to that, and because of that, a bad decision is taken. And I saw that in that company I told you about. I don't want to say that the name of that company. It's a very serious company. Who knows? Maybe they break out, but I saw that happen. So yeah, well, we are far behind the schedule. I know that you are in a rush. You have other things on the table, meetings and so on. And I want to thank Moti for the excellent. I've especially enjoyed watching the table that compared these two specific options. It helps a lot when getting the best, the right decision. It can help each and every of you that table, because it summarizes, in my opinion, everything, the most important thing. Okay, so thank you, Moti, for the great talk. Thank you, everyone, for attending, and I will arrange everything so you get the slides and the video. Yeah, Moti will arrange the slides somehow, and good luck, and have a great day, and take care.
Thank you. Thank you.
Thank you very much.
Bye.
Thank you.
Bye.
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 Bye.